word problems that involve systems of equations. And earlier this year, we could have had problems with systems, but we chose not to. Okay, we chose to make them all in one variable. And we did that by writing let statements. That made it a little easier for me. But now that we have gone over systems, we can definitely take a look at problems that involve systems and solve them using systems and not just those relationships between x and y. So let's look at the first. So Jim has $17 more than Sam. They have $73 together. How much money does each of them have? Probably one of the most basic applications of systems. And you'll see this early on in the SAT, one of those easier type problems. Now, if you're taking the SAT, you should write out your system and then go right into your matrix and calculate it in like 10 seconds. I would not do this by hand just because it's a time-based test. Okay, same thing goes for when you take my test. If I don't write solve this by elimination or solve this using algebraic methods, I'll probably write in directions for the word problems, set up the equations, and then solve using a matrix. So you'll literally write out the equations and then come up with the solutions all by using your matrix instead. So please practice that. And if yesterday you were a little bit confused on how to do that, if you go to videos from class, I put up a little video on how to do that. Okay, it's a short video. I don't think it was mine. I put it up like 3 years ago, so I just unhid it. But it's probably somebody on YouTube with a calculator showing systems and how to type them in and how to get the zeros and the ones in the right spots. So let's go through this. At the end, we'll do that application with the matrix one more time. So what would my first equation be? Jim has $17 more than Sam. What do you got, Chandler?
I was going to say x plus y equals 73.
Okay, so that's the second equation. So what's x and y? I would use j and s, actually, just because, right, because of that. You could use x and y, though, but j plus s equals 73. How do you know that, Chandler?
Because the sum of Jim and Sam's money is $73.
Yeah, it says it right there. $73 together. We'll let j equal the amount of money that Jim has, s equal the amount of money that Sam has, just so it's, right? So we use the first letter of the different one. And what's the other equation going to be here?
17 plus s equals j.
Nice, very good. 17 more than Sam is what Jim has. And that's exactly what Morgan just told us. So 17 more than Sam. So Sam plus 17 is equal to the amount of money that Jim has. Okay, Jim has 17 more than Sam. Here's Sam's amount plus 17. What method would you choose here if you're doing it algebraically? If you're doing it algebraically, Christian? What method would you choose? Elimination or substitution?
Elimination. Or I'm sorry, substitution.
Give me some rationale as to your answer.
You could bring j to the other side in the first one.
Oh, that's interesting. And then just set the equations equal? That's a really interesting approach. That works. So what Christian said is move s over or j over or get j by itself in the first one, and you could set them equal because they both equal j, which is in essence substitution. Okay, you could also do the same thing that Christian was mentioning by doing this and plugging that in right there for j. Okay, because remember the expression for j is s plus 17 from the second equation, so take that expression and plug it into the first equation. Okay, let's plug that into the first. So what Christian was mentioning was this, which works as well. You get j equals 73 minus s, and you could set this in a box equal to this, what's in that box. That's a really interesting way to do it because you're going to see that later in like pre-calc and calc, where you solve for a variable, same variable to equation, and set them equal to each other. That's what Christian was saying, which is really a good idea to do. Get both the j's alone, and then set them equal. It's the same result either way. Okay, it's the exact same result. So if I plug s plus 17 in over here, I get s plus 17 plus s equals 73. That's one way to do it. Or I set them equal, and I get s plus 17 equals 73 minus s. It's the exact same thing if you look at it. Okay, so setting them equal will give us this. Using direct substitution will give us this. So in blue is direct substitution. That's the same result as what you have here on the right in black. Okay, so either way works. What do you get when you solve? Yeah, well.
Well, I was just
Shoot.
thinking about it before. Like, personally, instead of putting another variable, couldn't you just do S plus 17. and then
Absolutely.
combine them.
Absolutely. And that's what we did in chapter 1, do you remember? So in chapter 1, we tried to avoid systems. So we said, well, let's just write, S plus 17 plus S equals 73, because S plus 17 is Jim, and then the other S is Sam. Well, that's kind of what we did here by combining and using substitution. So we'll just kind of jump the step, which is fine. You can come up with this directly off the problem. By all means, you should do that. Especially when you're taking a midterm exam. On the midterm, you're going to have problems that are systems. You're going to have ones from chapter 1, you're going to have word problems from chapter 2. So you have a lot of word problems. You have all these word problems you keep doing. So whatever method works quickest is the one I would definitely recommend. This is just demonstrating how to use substitution. But yeah, well, absolutely. You could jump right to this bottom right or bottom left equation, okay, by simply noticing that this is Jim's money plus Sam's money is 73. What do we get for Sam's money? What do we get for Sam's money? How much money does she have? Well,
$28.
$28. Okay, and if that's true, then how much does Jim have? If Sam has 28, what does Jim have?
45.
Yeah, and we know that because they add up to 73. Okay, they add up to 73. And how much do they differ by? Oh, look at that. 17. They differ by 17. Okay, so you can always check your work if you go back to the word problem and look at the context of the word problem. The next one is really challenging, so I encourage you to work with the person's problem. Once you see my answer and see how we do it, you can get back on. That's really easy. But let's see if you can figure it out on your own. Try to come up with some sort of an equation. Can we do this? Chandler, can you start over work with Jeff? Will, could you work with Alex back there? You guys here? 3 ladies here? You 2 back there? Perfect. So come up with the equations here. That's going to be the hardest part. Okay, remember that distance equals rate times time. That might help you. Remember D equals RT for this problem.
Use SAT.
If you think you have an idea, let me know. I'll come take a look. But forget to define your let statements. Can I help you? Defining what X and Y are will help you. Think about what you're looking for. Fine.
Use X and Y.
By the way, jet stream is wind, right? Technically, you can think of it as wind. Okay.
Oh, against the judgment, so that's against it.
you're having trouble visualizing, just take a look at the diagram I drew. That's kind of what you should have going on in your head right now. Okay, when it went with the wind, it took 3 hours. When it went against the wind, it took 4 hours. That's what will help you solve this.
Okay, so to find the wind, we need to find okay, no. I don't know anymore.
Anybody have an idea of an answer? Want to check? Ours is the same. You're correct. This is good. R is something of two variables. There's two variables. The speed of the jet and the speed of the wind. Those are two variables.
Oh, that's
Race
right.
against the wind.
What?
This is that framework, right?
Oh.
So,
Wait, but this is the rate of the plane, not the wind.
Exactly, and the second part of our question is the wind speed of.
you're on the right track, right? You got
So,
600 miles per hour, 450 miles per hour.
so it's like,
Right? Okay.
so that's what I'm saying, it would be the first equation.
How could you write that in equations? Like, what does it mean to be first?
Yeah, so like the difference.
So if I was traveling at 5 miles an hour and he was behind me pushing at 2 miles an hour, I'd really be at 7 miles an hour, right? What did I think of those numbers? How did I get 7? Yeah, so jet speed and the wind speed are together. The second equation for them. There it is. Explain it to Nico, make sure you wrote that in.
600 miles, so that's 3 without any wind. And then with it, it's 450. That's the difference. To find the rate of the wind.
Okay, so if I were you, sorry, I just got creepy. If I were you, I would call the one with 600 R1 and call the other one R2. Because they're two different rates, aren't they? You can't call them both R's at different times. R1 comes about because the jet and the wind act together, right? And R2 comes about because the jet and the wind act against each other. So if I was on a train and the train was moving at 20 miles an hour, and I were walking on the train at 5 miles an hour, this is relativity now, really. The idea is that I'd be moving at really 25 miles an hour relative to the ground, because the train is moving and I'm moving on the train as it's moving. So if the wind is with the jet, how could you write that? How would you write it? Okay, and then on the other end, just call it W plus X or X plus Y. And then on the other end, when they're against each other, the wind and the jet, what would you write? Yeah, or X. You use different variables because you already define R1, R2. So R1 is really like your X plus Y. R2 is really your X minus Y. Think about it for a second. Try and come up with the numbers, see if they make sense to you. You're on the same track as everybody else.
Wait, it's just why equals R1.
Now, 600 is when the plane has the wind with it, right? So if I'm running, right, I'm jogging, whatnot, and somebody comes up behind me, pushing me forward. If I'm running 5 miles an hour, that's velocity, and somebody pushes me with a little bit of velocity, like 1 mile an hour, and then I'm going to go 6 miles an hour. Or if I'm running into the wind and the wind is pushing against me, it'll be slowing me down. So when the wind is with the jet, you have to do up with their velocities. Yeah. When the wind acts against the jet, what would you do?
We're at it, but these
Yeah,
can't.
so why don't you define X and Y?
Oh,
Yeah,
yeah.
exactly.
My
Okay,
bad.
well, what should we do with those? R1 is this x plus y times these two, right? The plane is traveling, and the wind is helping.
Okay, so
Now the
then
wind
I'll
is
give
not
that
helping,
one.
it's going back.
Okay,
So
so
then
then
it equals
75, yeah.
Why didn't the
So we could formula. Wait, no, I'm not that fast.
That's good. That's good. Can I show you guys?
Okay.
Here's
See where you're here and here?
Okay, so the wind, wait, so which is which?
Why is it so wide?
Which in the end, you took this up.
Oh, so 75 is for grades.
All right, so every group kind of has it at this point. Now, a lot of you got stuck where you had R1 and R2. You got 450 and you got 600. Now, R1 is 600 because that's with the wind. I'm the plane flying and the wind is helping me. Now I'm coming back home and the wind is pushing against me. So R2 is the 450. But it was important to define the variables you're looking for. That's what helped a lot of groups, I think. So we start by saying right away, well, let's call X the jet speed, and let's call Y the wind speed. So when the jet and the wind are acting in the same direction, it only takes 3 hours. So I could start by writing this. I could say, first of all, we know this is the equation, the general equation we're going to use, D equals RT. Distance is always 1800 equals the rate. Well, when you're with the wind, it helps your rate. It increases your speed. So no longer are you traveling at X velocity, but it's X plus the wind helping you. And that only takes 3 hours.
It's still air, does that mean like the speed would be in between the
Still air just means the jet speed. So the speed in still air is what X is looking for. The speed if there were no wind occurring at all. The
It just
jet
happened to
speed.
be like that it was between 600 and 450.
So our answer, say again?
It just like happened that it was between 600 and 450.
No, it's equidistant from the, I'll show you once we get the numbers. You'll see where that comes from. It doesn't just happen to be in between the two. But when the jet is traveling against the wind, we have to subtract the speed of the wind. And how long does that take? 4 hours. Does that make sense that it takes more time? Okay, you're traveling against the wind's going to slow you down. So this is what I would have written. Now, the second part that a lot of you did, which I recommend just think outside the box here, if you want to get this to be a system, I would get rid of the 3 and the 4 by dividing. I would not distribute the 3 and distribute the 4. It's more work in the end because you're going to have to then divide through later. So I would simply just divide by 3, making this 600 equals X plus Y. Divide by 4, this becomes 450 equals X minus Y. Now you could use a matrix or you could literally add straight down. That's the Y's. The Y's cancel. It's not a coincidence. The Y's cancel out. Giving you X plus X, which is 2X. Okay, so add straight down. This gives you 2X equals 1050, which makes X 5 1/4. So that is the speed of the jet without the wind. Everybody, add what number to get to 600? Subtract what number to get down to 450? So what's the speed of the wind? 75. Okay, it's not a coincidence that the 525 happens to be between 450 and 600. It's the average of the two, really. It's the midpoint. Okay, so this is 75. So again, X is the speed of the plane or the jet in still air, meaning without the effect of the wind, it would go 525, which is actual speed of an airline. They're around 500 miles an hour when they're at a certain or about 30,000 feet above. This is like a commercial airline. And then the wind, 75 miles an hour, that's actually a reasonable wind at that height. Okay, not down here on the earth on the surface, we're not going to feel wind like that. Well, we could, but not normally. Okay, so some kind of a problem here where it makes you really think outside the box. Not so easy off the top, but once you see how to do it, you're like, oh, okay, that's all it is. And the idea here is this. You're really learning physics. You're learning about vectors. Vectors can be summed together if they act in the same direction. If vectors act against each other, they are subtracted from one another. That's really what's happening here. Okay, the velocity of the plane plus the wind gives you the velocity of them together. But the velocity of the plane against the wind means we have to subtract the two of those. And this is our rate 1, and this is rate 2. which some of you defined as R1 and R2, and that works also. Okay, but you have to use x plus y and x minus y to get the individual answers for each of these. Questions at all before I go on to the next one? Okay, let's take a look at the next one then. Next, you please.
Okay, so let x is 2.5 y equals 5. That's 5 y. No.
Do me a favor and write your let statements. Don't forget to write let statements. Please write let statements.
And then try to multiply. Wait, and then what's the x plus y?
Yeah, negative 2.
Make sure your units make sense. The units have to match up. Use your matrix to solve this if you want to check. Okay, please after you've done it. Questions on the test.
Yeah. Let's get y equals 3.
Yeah.
X is number 2
So then,
pointers.
I don't think we need
Y is
to
number
finish
5
this.
questions.
No, it's not.
So we have to
So
ask
there's, and it means
It's the easier
that,
equation too. And then try to go with the second equation. Good, that's the first one, right? Did you go get the first one? Okay, so the first one's the easy one. Try to go with the second one. Utilize the 145. Okay, you guys look at where this is coming from? Yeah. What equations you get? Why don't you start with the...
I didn't want to do it.
Still not. Why don't you start with the fact that together there's 50 questions, right? Are there 50 questions below? Together there's 50 questions. Yeah, that's your first one. That's the easier one. Get the harder one now.
That's 16,
There's
35.
35 is 50.
So,
2 that's 35.
35.
Yeah.
Oh, you said 30?
Yeah.
15 minutes, 15 seconds.
Did I write?
That's fine. Everybody came up with this one already, it looks like. Okay, this is the easier version or the easier equation. This is the equation that relates the number of questions. How do I know that's the number of questions? Because look at your units. What are the units of 50? 50 questions. X amount of questions, right? Number of questions. Y questions. So some amount of questions plus another amount of questions equals total of 50. That's the easier equation. The other one, what do we have to do for the other one? And explain using units to do the other one. How would I do the other one and explain it using units? And a lot of you got the right equation, but I don't know if you'd be able to explain it using units. Let's see if anybody can do that. What are the units of the other thing? We've used 50 already, right? We've used this, that's done.
2x plus 5y equals 145.
Give me explanation with units, though. Remember, that was the task. You're right, that's the right equation. What are the units and why? The number 2 has what kind of units?
2 times.
This is what Christian said. I want the units though. And I'm going to explain why I'm really being annoying about this. Okay, you're right. 2x plus 5y equals 145. But what are the units for each thing? The units of 2. Points. Almost done. It's not right. It's not just points.
Like when you put an equation in standard form, isn't it?
What are the units for 2, guys? It's points what? What is it?
Points per question.
There it is. Okay, so this is points per question. Follow me. This will make sense. What are the units of x? Number of questions. What are the units of 5 again? And the units of y are questions. So when you multiply this out, the number of questions as units cancel. And what are you left with? You're left with points plus a certain amount of points equals 145 points. So if you get stuck when you're doing these kinds of problems, think about the units each thing has. 2 points per question times as many questions, plus 5 points per question times y amount of questions equals 145 points. Why is everything in points? Because questions cancel. Questions cancel. Denominator, numerator, multiply, equals cancel. So you're left with some amount of points plus some amount of points equals some total amount of points. Okay, giving us this, which is what Christian had mentioned. Now, if I want to solve these 2 equations together, this one and this one, I'd probably multiply this equation by -2 and add it to this so it cancels out the x, or multiply this by -5 and add it to cancel out the y, or simply go to your matrix. Okay, if I go to my matrix, it'll be like this. 1, 150, 2, 5, 145. Okay, if I do row reduced echelon form of that, I'm going to get 1, 0, 0, 1. What do I get as my numbers for x and y respectively? 35 and 15. Okay, that's what my matrix would look like, which if you recall, this really means 1x plus 0y equals 35. And the bottom line really means 0x plus 1y equals 15. So as a result, we really know that x is equal to 35. Okay, it's this first number here, and that y is equal to 15. That's the second number right there. Okay, I would really honestly prefer you to use your matrix on word problems. So let's do the next one, but once you get the equation set up, please go to your matrix right away. Okay, let's try that. Oh, and I just said matrix. This is one of the few. Oh no, you could use a matrix for this one actually, but just be careful. To use a matrix on this one, everything needs to be in the correct order, like all the x's, all the y's, all the z's, and then all the constants. Okay, 3 variables here. Try writing it on your own. Each of you try writing it on your own. See first. Give each other a minute to understand and comprehend on your own first. Then talk about it. So we each get a try. 3 variables need to have 3 equations. We're going to have 3 variables. First equation, I think everybody probably got right away. What's the first equation?
J plus B plus A equals 70.
Okay, very good. That's your first one. Now, right away, and this is something Sarah said, there's 3 variables, so how many more equations do you still need after the first one? Just thinking, how many more? Yeah, you need 2 more to get a total of 3. So figure out what those other 2 are. Now, you can solve this with substitution. It does work, and it's not too difficult with substitution, actually, it turns out. But, I mean, you could try with systems as well, or with matrix as well. It says, then together Bob and John and Bobby have $39. What would I write there? How would I write the second part? How would I write the second part? Chandler?
J plus B plus 39.
And look what I'm doing. Take a look, please. Why did I do that? Why did I do that?
There's no K.
Okay. What does that do to me? But why? Like, I could have just written it right here, equals 39. Why do I leave space? To remind me what? I'm using a matrix. You need to put a 0 here for k spot in the matrix. We're going to do this. Okay, that's the point. That's the reason I left the space there. Whenever you're missing a variable, if you write it as a system with matrix method, you have to have a space for it, or just remind yourself that there's a 0 there, not a 1. Okay, because all these other coefficients are all 1s, actually. The last part says, Kristen has $4 more, or $4 more than Bobby. So the last equation is Kristen has 4 more than Bobby. But that doesn't look like it's in the right form. So I could do one of two things. I could use substitution method and find a way to solve this using substitution. And that will work, but it's a little bit messy. All right, Kristen has 4 more than Bobby. Or I could just rewrite that last equation. I want to rewrite it in the form where it's j plus b plus k equals some number. So how do I move that b? That b is on the wrong side. How do I get rid of that b? Yeah, let's subtract it over here. Move the b over. Okay, subtract b from both sides, and this would become negative b plus k equals 4. So again, I'm not going to use this. I'm going to use what I wrote down at the bottom here as my third equation. I'm going to move the b over, which makes it a negative b, a positive k, a positive 4. So negative b plus k is equal to 4. And now I have a system, and it's in the right order. So my matrix would look like this. 1, 1, 1, 70. 1, 1, 0, 39. 0, negative 1, 1, and 4. Okay, there'd be my matrix right there. Does that make sense, what I'm showing you? Yeah.
I solved, like, I put it in like a different order when doing the k equals 4.
That's okay, as long as it's consistent. As long as all of your j's are in the same column, and your b's and your k's, as long as they're in the same column, you're okay. And your constants need to be on the right-hand side.
Okay, but I got like 0, 1, negative 1, negative 4. Would that make a difference?
Again, yours are just in different orders, right? Isn't that what it is? Like I have 1, 1, 0, 39, 1, 1, 1, 70. Here, if you had a negative 4 here, this would be a positive 1, and this would be a negative 1. Is that what you had? Yeah, because you just multiplied the last equation all by negative 1. So it doesn't affect the problem. Think about it. If you multiply both sides of an equation by a number, it's still the same equation because of the multiplicative property of equality. So you could multiply all these numbers by negative 1. This would be 0, 1, negative 1, negative 4. And that still works. Okay? Go to your calculator. Type this in your calculator. We have 3 rows and 4 columns. 3 rows and 4 columns. James, you were here yesterday. Can you show Morgan how to do this on the matrix on the calculator?
I'll try.
Please try. Go to your calculator. 3 rows and 4 columns. By the way, we're probably going to run out of time. There is a 5th problem. Try it on your own and check my notes or check the other video I recorded before you go to the homework tonight. If you try the last problem, hey, don't just give up. Try that last problem also, example 5. If you're done with this one, you can go right on to it now. I'm going to come around just to check on your matrix stuff. Raise your hand if you have questions. Go over to edit, hit enter, make sure you can re-enter over matrix A. Make sure you guys are following along. So you go over to edit, to enter something into a matrix, hit enter. Okay. Then change to 3 by 4. This is the amount of rows, this is the amount of columns. And if you look at that box there, it's got 3 rows and 4 columns. So you press 3, enter, 4, enter.
Yeah.
Now, all you have to do is type in the coefficients for the system. 1, 1, 1, 7. So 1, enter, 1, enter, 1, enter, 7, enter. So type all those in, you see in the box there, okay? And Morgan, those literally are coming from the, you see where they come from? I'm taking the coefficients of every variable and placing them in there. Yes? A second, wait. Go back to the matrix.
Oh, I didn't see.
Go over to that. R, R, E, F. Letter B. R, R, E, F.
No,
Enter.
or
Back to the matrix one more time.
Because it makes sense.
Go back to the matrix. There it is. Check your numbers with each other, please. And Emily, show your friends how to do that,
Okay.
please.
So, and then you go to second clip. And then,
So that means there's mistakes on there, right?
Yeah.
yeah,
Oh, there, you see that, I'm good.
And then I did that,
and then I went
You- Oh, but then you go, yeah, so you're gonna go back to the matrix, and put matrix A, so you enter it in. There, so the difference you put the alphanumeric character.
and then second mode, and then you have to go
Hit enter,
down
so
to,
you get it?
you go over to mountain and then down to.
Yeah.
Okay, so once you enter everything into the matrix, you can press second, second,
Okay, go back to your
go
numbers.
back to the second matrix.
Which one?
The one that
You wanna do something called a row reduced echelon form, and it's just RREF, so you wanna remember. So go over to math,
Okay, like.
Go down.
Yeah.
until you get to the letter P,
And
which
then
is RREF, and then turn that,
second clip,
and then press matrix again.
okay, second matrix.
Instead of going over to edit now, we want to use matrix next, we're going to enter matrix now. And what this is going to do, it's going to manipulate the rows, and it's going to do elimination for us. Remember elimination method? When you hit enter, take a look at your answer.
A was already
You
in
have
mine 'cause I
12,
just
27,
used
31 as your numbers. What this means is 1J plus 0B plus 0K equals 12. So simply J is 12. And then here, you can say that B is 27 and K is 31. It literally gives you the answers for you. It's a way of checking. So when you do the test and the word problems, you can use your matrix for that. Okay? You have to still be able to do it by hand. Yes, we learn how to do it by hand with 3 variables and 3 equations. But doing it on there for the word problems makes more sense. There it is. Good. So remember, this first column represented J, isn't it? So that first one there, that's J's value. And the second column, that represented B. So this represents 0J plus 0K is equal to 27. So pretty much B is 27. And there's our K is 30. Good. Now list out your answers. Call it, this is really J plus 0B plus 0K is 12. So J is just 12. I mean, listen to me.
You when you do RREF.
Say again.
Why didn't you use the one yesterday? It's 3
So you got, oh, so here's the thing.
Yeah,
When you're in the matrix like this, you can't do this for you quit out first. Then do REF, or you're pulling up REF inside the matrix there. Just put out to REF. Back to matrix, small matrix
Wait, you lived in the house? Yeah. Did you do that? Can you go to the house?
J12, B, 27, K. Do you understand the significance of your answer? Remember this first column with all the J variables?
Yeah.
So this tells us 1J plus 0B plus 0K is 12. So J is 12. Here's the middle column, you look there with B. B is 27 and K. Make sure you do number 5 tonight, guys. Do the homework. You are. I am, but give me a minute to like settle. What's up?
Thank you.
Oh.
Just wants you to work on physics. Like more activities period here, so.
I know, but I can't work with you for the next 2 hours, you know, right?